Hi children, today we are going to study about electric current and its effects. You had studied in 6th standard the electric circuit, the closed circuit and the open circuit, and what are the things required to make a circuit. What are the things required to make a circuit, children? Cell or a battery, wire, bulb, switch, etc. So here we are going to study about how this circuit, see here we have used the cell, wire, bulb, switch. So what is meant by switch? Switch is a device which is used to open or close the electric circuit. So here we have drawn the object as it is. But now in 7th standard you are going to study about the symbols. We are going to use the symbols used for the electric circuit. So now these are the symbols. Electric cell means one long line and the short line. The long line shows the positive terminal and the short one shows the negative terminal. Now electric bulb, it is the electric bulb symbol. Now this is the switch. In the circuit you prepared by using the pin. So the switch is closed. So otherwise it is in on position. Now it is open, so it is off position. Now battery. What is meant by battery? Battery means two or more electric cells are required to be connected in many of the electrical devices. So, two or more cells are arranged in such a way that electricity passes through it. So, the combination of two or more cells is called the battery. Now, next one is a wire. The wire symbol line is used. So, here battery means here two cells are shown, here two symbols are given. Now next one, here in this picture, how these cells are connected. The battery of two cells are connected with positive and negative terminals touching each other. Now here, the connecting two cells together to make a battery. So how it is connected, you see. So this is the way we have to connect. Now next one, the electric circuit already you studied in 6th standard. Now how this electric circuit is drawn, circuit diagram is drawn using the symbols. You see here the positive negative terminal is there. It is connected with the bulb and connected with the switch. So it is, the switch is closed, otherwise it is on position. So the bulb is glowing. Now here the switch is off position, so it is not glowing. So we can say it is a open circuit. Now in this, in the bulb there is a thin wire called a filament. So which glows when the electric current passes through it. When the bulb gets fused, its filament is broken. Now what is meant by filament? So in that one we will study in the next topic, that is heating effect of electric current. Now take an electric cell, a bulb, a switch and a connecting wires. Make an electric circuit. This activity has to be done using only one cell. Keep the switch in the off position. Does the bulb glow? Touch the bulb. Now move the electric switch to the on position and let the bulb glow for the minute or so. So when you touch the bulb when it is in on position, you feel hot. So here the wire gets hot when an electric current passes through it. So this is the heating effect of the electric current. The heating effect of electric current is used in several appliances which include electric toasters, electric irons, hot plates, electric hair dryers, and electric ovens. These appliances contain tightly wound coils called elements. An element heats up when an electric current passes through it. So in some appliances it is covered and some it is open. So if it is open, you can see the dull red glow when the appliance is on. The amount of heat produced in a wire depends on its material, length and thickness. Thus, for different requirements, the wires of different material and different lengths and thickness are used. The wires used for making electric circuits do not normally become hot. On the other hand, the elements of some electric appliances become so hot that they are easily visible. The filaments of an electric bulb gets heated to such a high temperature that it starts glowing. If a large current passes through a wire, the wire may become so hot that it may even melt and break. But is it possible for a wire to melt and break? Let us check it out. So, what will happen if a large amount of electric current passes through an appliance? It causes the wires to get overheated and the appliance get damaged. This situation arises as a result of some fault in the circuit and can be extremely dangerous as it can lead to a fire. So to prevent electric appliances from getting damaged from an excessive flow of current, a safety device called fuse is used. A fuse is a safety device used in an electric circuit. An electric fuse prevents a large amount of current from flowing into any appliance or device as it cuts off the supply of electric current, thus preventing the further damage. So what is meant by a fuse? A fuse is a device which prevents the electrical appliances from getting damaged. A piece of thin wire of the special type of material, that is alloy of tin and lead, is tied in the holder made of porcelain such that it joins the two ends. The fuse wire is such that it melts easily. When the amount of electric current in the electric circuit exceeds the fixed limit, the fuse wire melts. This is called as the fuse is blown off. Now, due to blown off fuse, electric circuit becomes open. So, the electric current stops flowing in an electric devices and thereby they are prevented from any damage. Incidents of fire also stop. In case of the blown off fuse, new wire can be tied and the fuse again start working. So the first effect, it is heating effect of electric current. So because of that, many appliances are used in our homes also. Now the next one is called the magnetic effect. So what is meant by magnetic effect? Take a cardboard tray, from inside discarded matchbox. Wrap an electric wire a few times around that cardboard tray. Place a small compass needle inside it. Now connect the free ends of this wire to an electric cell through a switch. Note the direction in which the compass needle is pointing. Bring a bar magnet near the compass needle. Observe what happens. Now, while watching the compass needle carefully, move the switch to the on position. What do you observe? Does the compass needle deflect? Move the switch back to the off position. Does the compass needle come back to its initial position? Yes. Repeat the experiment a few times. then we will we will come to know that the needle of a compass box is a tiny magnet which points in north-south direction. When we bring a magnet close to it, the needle gets deflected. We have also seen that compass needle gets deflected when the current flows in the nearby wire. Can you connect the two observations? When the current flows through a wire, does the wire behave like a magnet? Yes, this is proved by a scientist called Hans Christian Ørsted. He was the first person who noticed the deflection of compass needle every time the current was passed through the wire. So, when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. It can be used in many devices. So, how you can make the electromagnet? Take 75 centimeter long piece of insulated flexible wire and an iron nail. Wind the wire tightly around the nail in the form of a coil. Connect the free ends of the wire to the terminals of a cell through a switch as shown in the picture. Place some pins on or near the end of the nail. Now switch on the current. What happens? Do the pins cling to the tip of the nail? Now switch off the current. Are the pins still clinging to the end of the nail? So from this what we have observed is the coil of a wire behaves like a magnet when electric current flows through it. As a result, the small pins cling to the end of the nail. When electric current is switched off, the coil generally loses its magnetism and so the small pins fall off the nail. So we can say when the electric current flows through the coil of an insulated copper wire wound around the iron nail, it behaves like a magnet. So these coils are called electromagnet. Now this electromagnet is used in the device like electric bell. You know that electric bell. What is the principle? The principle is it works on the principle of magnetic effect of the current. Now in this picture you can see a coil of conducting wire wound on an iron piece is fitted on a wooden board. The coil acts as an electromagnet. A soft iron strip is kept close to the coil. A hammer is fitted at its one end. A metal ball known as gong is fitted with the screw slightly away opposite to this hammer. One end of the electromagnet is fitted with the soft iron strip and the other end is fitted with the contact screw through the battery. So how it works? On pressing the switch, the circuit gets completed. So electric current flows through the coil and hence the coil behaves as a magnet which is called the electromagnet. Hence now the soft iron strip is attracted towards the electromagnet. At this instant, the hammer fitted at one end of the iron strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, the contact of the screw with the strip breaks and so the circuit breaks. The current flowing through the coil stops. The coil is now no longer an electromagnet and so it cannot attract the iron strip. The iron strip comes back to its original position and touches the contact screw again. The electric circuit becomes complete when the iron strip comes in contact with the screw and electric current flows through the coil. Hence, the coil again becomes magnet and again attracts the iron strip and the hammer strikes the gong again and produces sound. This process is repeated quickly and successively and hence the bell rings continuously. So children, what we have studied in this lesson is when the electric current flows through a wire, it gets heated. So that is called the heating effect of the current. This effect has many applications. Now, when the electric current is passed through the iron wire, it behaves like a magnet. So, these electromagnets are also used in many devices. So, read the lesson and to do your objectives in the textbook. Thank you.